Hi, my name is Peter Felfer, and this is another tutorial for my OpenVA analysis programs. And today what we're going to do is we're actually going to create some analysis objects. Actually, we're going to create one analysis object. And this is because we want to, of course, start with the simpler things, and one of the most common ones is a grain boundary. Grain boundaries in atom probe data are not very easy to outline with as a concentration surface. Actually, you can't outline them with as a concentration surface, really. Because they're not characterized by constant concentration. Whereas with gradient approaches like DCOM, which is what I'm going to use today, it is fairly easy. And for that purpose, I'm going to use Blender and a custom script in Blender that you can download from a web page. It's very easy to use. If you don't know what Blender is a free and open source 3D program that's very useful for working with 3D data in general. It's obviously made for animation and computer graphics, but it's also very useful for scientific purposes. And because of its animation and rendering background, it's also really great to make nice images of your data. So okay, let's get started then. So I'm working with Blender 2.67, latest version, as when I'm doing the video tutorial. It's got a few new things in it, but none of those are really relevant to what we're doing. But since it's free and open source, I recommend to work with the latest version that's out there anyway. So you start out with a default scene. We of course don't care much for the default scene. So I'll just switch on the screencast in case so that you can actually see what I'm doing. And the first thing is selecting all objects and deleting them because we don't need them. And what we need is our atom probe data. So we go and import that via import wavefront OBJ. And of course, in order to be able to import wavefront OBJs, you need to have a wavefront OBJ. And there's another tutorial on my webpage that shows you how to create the wavefront OBJs from the atom probe data. And the programs that you need to do that are actually on the page as well. So just click wavefront OBJ and I'll go into the folder where I have some of my data. It's a grain boundary in a superalloy. In this case, the grain boundary is best outlined by boron and phosphorus. So the first thing is I'll just click on the boron export, and then I need to scroll down here on the left side and click keep vertex order. That's a very important thing, otherwise it's not going to load the data properly. Just click that, import OBJ, and there we go. That's our atom probe data. That's the boron, to be more specific. We also want to have the phosphorus, so we'll go file, import wavefront OBJ, and select the phosphorus. Import that as well. And the next thing I'm going to do is actually go here into the outliner where you can see the objects, select both of them and join them so that they're one object, because we want to treat them as one object when we're targeting them. And the next thing I'm going to do is I'm going to duplicate them. And this is simply so that I have one data set where I can mess with and one that's the original data. So that one is just, let's just call it target, because this will be our target object. And we'll hide the one that's not our target object because we don't really need it. It's just always good to keep it in the background because later you might want to create a figure for your paper or something like that, and then it's just there. Next thing is we only need a certain region. So it makes the entire approximation go faster if we remove all the atoms that we don't really need. And to do that, we'll go from object mode, where we're dealing with entire objects, to edit mode, where we're dealing with the data inside the objects. So right now we've got all atoms selected. So let's just deselect all atoms. And here you see, which is circle select. We'll also need to switch into wireframe mode, because otherwise if an atom is behind another atom, it will not select it. In this case, we don't want that. So just press Z into wireframe mode, circle select again, and we'll delete all the atoms. First of all, we'll mark all the atoms that we don't really need because they're not in the vicinity of the grain boundary, so they're not going to do anything in the analysis. or at least not in the definition of the objects, and then press X and vertices to delete them. So the next thing is we actually really need to know what the boundary of the data set is. You sort of can know it by looking at the atoms, but it's not a very precise outline. The exporter script, on the other hand, gave you the concave hull of the data set, which is a precise outlining of the data set. So we'll go File, Import, Wavefront OBJ, and you'll find the hull here. So it just ends on hull. And here it doesn't matter whether I have split or keep vertex order. Just press that, and there we go. We've got our outline of the data set. So if we switch it into solid, you can see that's the outline of the data set. And you can see it's got our data inside. Next step is, so for now we don't need the hull either. So we'll just go and click on the hull here and press H to hide it. And then we don't need that part as much anymore. So there we go. There we've got our data. And so now we've got the 3D cursor there. And if we add our analysis object, it will actually edit what a cursor is. So if your cursor is not right at the center, press Shift S and go cursor to center. Then your analysis object, the origin of the coordinate system, local coordinate system of analysis objects will be at the origin of the world. And we want that so that later when we are manipulating our objects, which we might do for animation purposes, or if you want to, I shouldn't probably say it already, but if you want to use it for reconstruction, other purposes, it's good to have all of our objects initially at the same position. So we'll just go Shift A for adding an object, and we're adding a plane because it's a planar object that we have, and we call that plane grain boundary. Simple. And then, so now we actually want to move that plane so that it as best as possible matches the grain boundary atoms here. But we're not doing it in object mode, we're doing it in edit mode. Very important thing, because then we're moving the vertex coordinates and not the object coordinates. Again, later when you want to do things with the object, that's pretty important. So you go and have everything selected, all of the vertices selected, maybe scale them up, say 20 times, so that they have roughly the same size as the data down here. And we want to rotate it by 90 degrees and grab it so that it's roughly, and it will make a nice outline. So next step is to produce vertices, because right now we've got a mesh that only outlines this quad and will not give us a very precise approximation of the grain boundary. Actually, it will not give us one at all. So we'll go and subdivide the mesh so that it has a decent size. So 10 cuts in this case looks like we maybe want more, and that looks about alright. So this is sort of the equivalent to binning when you generally do anything with data. So it does have an influence if you want to do things like interfacial access mapping, but for that purpose there will be a more in-depth tutorial, of course. But for now we'll leave it at that, and deselect all of the atoms, and this is our object. So you can see now our plane is approximating the grain boundary, and this is the point now where the hull comes in again. So you can see now that some of the grain boundary approximation extends beyond the hull of our data set, so we need to remove that bit. And the hull is not usually watertight, so it's not a manifold, which means we can't use the Boolean operators of the program, which if you have a really nice outline, you can do that. But in this case, we're going to do the manual version, which means we're going to select the data, tap into edit mode so you can see the mesh again. And now we're actually not in wireframe mode. So this is wireframe mode, this is solid mode. We're in solid mode, And in solid mode, with the circle select, it's only going to select the things that are visible to us, which is good because it means that those things, those vertices that are actually outside of the hull of the data set. So we'll go and do the whole cookie cutter thing. We'll actually select a bit more if we move inwards, because you can see the faces, and that's pretty much what we want. Shouldn't select too much inwards, but since the hull is not actually very dense, it sometimes will have problems with that. So let's just see what we have selected, but that looks quite all right. And we'll go and delete the vertices, switch back into it, and hide the hull again. Now you can see we've got a fairly decent approximation. Maybe we've deleted a little bit more than we needed to, so we can let's just do it manually. You can, for example, I think we will get away easily with these vertices being part as well. So just a little bit of manual cleanup, but here I'm not entirely sure. That one can probably, anyway. So this should be, this should be an alright approximation. And the next step is actually loading the script. So we need the script that allows us to do the relaxation steps. To do that, you'll go into here where you see the different layouts of Blender, and you go into scripting mode. And you go text, open text block, and you go wherever you've saved the script that is downloaded. And the only thing you need to do then is to go and run the script. Sorry, it's a small screen. Run the script, and then go back in your default view. And now, if we go into edit mode and scroll down, you will see the DCOM panel here, which is distance to center of mass. So it minimizes the distance to the center of mass within a sphere of a radius r, which is the radius here. And 5 nanometers is usually a pretty good value for most larger data sets. It's a bit of a smaller data set, so I know 4 works pretty well. Dimensionality is 2D, so it's a 2D object, and the target is the target. Easy. And then we can do the approximation. So the approximation only works on selected vertices. So right now we want to approximate, and this is also, this is just because if you've got very large objects, you want to do relaxation just parts of it, just because then it's fast and it's a bit more responsive. So just select all of them and press DCOM step, and you will see it converges pretty quickly. Snaps to the grain boundary, converges pretty quickly, and that is it. You can actually use that and export it and create, for example, a proximity histogram from it, or an interfacial axis calculation. If you want to do some visualization, it's maybe advisable to clean the mesh up a little bit, so you can, for example, go and create some nicer faces in the corners so you don't have the ear standing off. But that doesn't actually make a difference for the analysis, really, because the approximation is that tangential continuity. So if you have a part of the data that's not covered by a face, it will still be properly worked on. It will just assume that the mesh continues tangentially where it's beyond this point. So if you go here, you can see inside, and you can see where our grain boundary object is in there. And in order to export it, you just select the grain boundary and go File, Export, Wavefront OBJ, go back into wherever you were, Usually I just go into here and go grain boundary underscore 4 nanometers so that I know which DCOM value I've used, and go and in the export settings go selection only, because otherwise it will include all of the other objects as well. And then you can just go and export OBJ, and if you look here, you've got your OBJ and you've got a material file as well, but we don't really need the material file. The OBJs are very simple files. If you look into the file, you can see it's just vertex, 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 and then it says which vertices are connected into faces, and that is it. The only thing that we're not going to use is we're not going to use the material library. You can either leave it in there, my programs will recognize it and throw it out later, because we don't have a material in the sense of a 3D program. In the way a 3D program works in this, so you can go and delete it, and also go here, use material none, and switch the shaders up as well. But you don't need to do that. Anyway, but you can see it's here, and if you want to do analysis, this is pretty much all you need. So you can finish the tutorial here. If you want to know a bit more about these things, I'll show you a few more things. But in order to do analysis, that's pretty much it. So if you're still here, then I'll show you some other things that you can do with the grain boundary, which is just making it look a little bit nicer. So, for example, if you want to use that, for a paper, then the first thing you would want to do is well, get rid of the target in the sense that it's not going to be rendered, which is the camera here, and you don't want it to be selectable either. The hull we can switch off for now, and the other atoms you want to have displayed usually as spheres. So you go snap cursor to center, and you at the center add a sphere, because an icosphere in this case, and make it 0.2 nanometers large, and we'll call this atom. In this case, of course, you would usually import the boron and the phosphorus atoms separately and do it separately, but for the sake of the tutorial, I'll just do it this way. And then you'll go into the atoms and you'll go duplication vertices and drag and drop the atom onto here. Now you can see every single atom here is an atom here, right? And we'll also give it a material, so just press new material, and we'll do it in cycles, in the cycles renderer actually. So go and change from here to cycles renderer, add a new material, diffuse material, we'll make it green, and the grain boundary, will make the grain boundary a different material. So press new material and make the different material the red material. Yeah, maybe like that color. And there we go. The only thing is we need some light, so we'll just use some global illumination. So just go onto world, click surface use nodes, and a white color, and we'll adjust the strength when we're in rendered mode. You can see here now we're rendering live, and the strength maybe 0.5. No, one was quite alright. So you can see here now you've got the grain boundary object, you've got the atoms, maybe a little bit of, so I'll go here in the atom. Oh, sorry, I didn't give the material to the atoms, I gave it to the mesh, which is stupid, need to give it to the atoms. There we go now, I've got the atoms. And we also might want to display the hull, so probably not the entire hull though, so just go and select the hull, go into edit mode, select half of it, and delete the vertices. And we'll also give it a new material, and in this case we'll give it a glass shader, or velvet shader. I like the velvet shaders, they're nice. And a little bit of a bluish, what color doesn't really matter. And then go to render again. Okay, something didn't go quite the way I had intended to. So we'll go into edit mode again. I think I just was so there we go. Get a very nice rendered image of your dataset. Of course, you can play around with the lighting, you can play around with where things are because there's a bit shadow in there. But yeah, this is our first analysis object created. You can see it's not particularly complicated.